confidence intervals and confidence levels for sample proportions. To introduce this, suppose that we are interested in a 90% confidence interval. Consider a standard normal variable to begin with. So here we have a standard normal with the mean of 0 here. There's 90% of the area here, so that would be a 90% confidence interval. And that means 5% at this end and 5% at that end, because when we take confidence intervals we always do it symmetrically. If we look at the value marked Z on the x-axis, 95% of the area is below this 90% and this 5% here, making the 95%. We can find the value of Z using InvNorm. So interactive distribution inverse InvNorm, and we could use left at 95% or center at 90%. Let's use the left and go for 0.95. The settings here are for standard normal, and we can see 1.644 and so on. So we can see the Z value is approximately 1.645. As the standard normal is symmetrical about 0, the symmetric value to the left of the mean, such that 5% of the area below, is negative 1.645. So this one is 1.645, this is negative 1.645. We know that we can find the equivalent values for non-standard uniform distributions by transforming, which means multiplying the Z value by the standard deviation, and adding the mean. So that's a movement of location by adding the mean, moves it along to a new mean, and multiplying changes the shape of the distribution. So the 90% confidence interval for a sample proportion p hat is p hat take away 1.645, which was this Z value, times the square root of p hat 1 minus p hat over n, which we know is the standard deviation, and then p hat plus the same thing. So this would be our confidence interval. For a general confidence interval, not just 90%, then all we do is take the 1.645, which was specifically for 90%, and replace it with the Z value for the confidence level that we want. The quantity Z multiplied by the standard deviation, which we can see appears here and here. Remember, that's the distance up from the mean, the distance down from the mean, and therefore it's the margin of error.